You know, the most incredible thing about our universe is also the most frustrating thing about it, and that's just its size. It's so mind-bogglingly huge that even if we found the perfect planet out there, getting to it seems impossible. So let's really get into this cosmic problem.
Okay, let's put this in perspective. Our closest galactic neighbor is Andromeda. If we hopped in one of our fastest spacecraft right now, it would take us 94.5 billion years to get there. I mean, even if we could somehow travel at the speed of light, we're still talking 2.5 million years. It's kind of a bummer, right? What's the point of discovering all these amazing places if we can never, ever reach them?
Well, what if there was a cheat code, a way to just bypass all those millions of light years of empty space, a shortcut that could take a journey of millennia and shrink it down to months, or hey, maybe even minutes? Now, this is where things get really interesting.
And that potential shortcut has a name you've probably heard before, a wormhole. Now, I know what you're thinking. That's just sci-fi stuff. But here's the thing. It's not just science fiction. The idea is actually grounded in some of the most profound real-world science we have.
Yeah, you've definitely seen this in the movies. Think about Interstellar, right? The crew finds that wormhole out by Saturn, and bam, they're in a completely different galaxy. It's how they make an impossible journey possible. And what's so cool is that the way they showed it wasn't just some wild Hollywood guess. It was based on actual scientific theory.
So what exactly is a wormhole? Well, the official fancy name for it is an Einstein-Rosen bridge. And what it is a hypothetical tunnel that punches right through the fabric of spacetime, creating a bridge that could connect two incredibly distant places, maybe even different points in time. Or, who knows, maybe even different universes.
Okay, this is the classic and honestly the best way to picture this whole thing. Imagine you've got a piece of paper with two dots on it, far apart. The shortest way to get from one to the other is to just draw a straight line, right? Simple. But what if you could cheat? What if you just folded the paper over so the dots are right on top of each other, and then poked a pencil straight through them? All of a sudden, that long journey is basically no journey at all. That little tunnel you just made, that's the basic idea of a wormhole.
And you know, this brilliant analogy is actually where the name wormhole comes from. Back in 1957, a physicist named John Wheeler came up with this great comparison. He said to think of a worm on an apple. It doesn't have to crawl all the way around the outside to get to the other side. It can just burrow right through the middle. A wormhole. The name was perfect, and it just stuck.
So where did this completely wild idea even come from? Well, it wasn't a science fiction writer. It came from the most famous physicist in history. The cosmic blueprint for wormholes is hiding inside Albert Einstein's groundbreaking equations about the very fabric of our universe. You know, this idea didn't just appear out of thin air. It was a slow burn. It all started back in 1915 with Einstein's field equations. A year later, a solution to those equations predicted black holes. Then, in 1935, Einstein and his assistant, Nathan Rosen, found another solution, this bridge that connects two points. And it took another 20-plus years before John Wheeler finally gave it that catchy name.
All right, deep breath, here it is. One of the condensed versions of Einstein's field equations. And I know, it looks incredibly intimidating. But don't worry, I promise, there's no math quiz here. You don't need to solve this to understand the absolutely incredible meaning behind it.
So, what does all that really mean? At its heart, it's actually pretty simple. All it says is that mass and energy tell spacetime how to curve. That's it. Think about spacetime like a giant stretchy trampoline. If you put a heavy bowling ball in the middle, the trampoline sinks and curves, right? Well, that's what planets and stars do to spacetime. The heavier the object, the deeper the curve.
So if wormholes are tunnels, how would one even form? Well, the recipe, theoretically, calls for two of the most extreme and bizarre objects that the universe could possibly create.
Think about that trampoline again. To make a curve so deep that it actually punches a hole all the way through to the other side, you'd need something with an almost unimaginable amount of mass and gravity. So, what kind of object could possibly do that?
The theoretical answer is a black hole. Its gravitational pull is so powerful, so immense, that it could be the very thing that wrenches spacetime open, creating the entrance to our tunnel. It's the ultimate cosmic drain, pulling everything in.
But hold on, there's a big problem here. If you fall into a black hole and the exit is also a black hole, well, you're not going anywhere. You're just trapped. For this to be a real tunnel, a true shortcut, you need an exit point. You need something that does the exact opposite of a black hole.
And that brings us to the white hole, A white hole is another one of these theoretical things that pops out of Einstein's equations. It's the perfect opposite of a black hole. Nothing can get into it from the outside, and matter and light can only burst out of it. It's a one-way exit door.
This slide breaks it down perfectly. A black hole is the entrance. It pulls everything in, and nothing can escape. A white hole is the exit. It pushes everything out, and nothing can get in. You put them together, and theoretically, they could form the two ends of a traversable wormhole.
But do white holes even exist? That is a huge debate in physics. Some scientists think they might have been formed at the very beginning of the universe, during the Big Bang. Others wonder if a white hole is what's left over after a black hole finally evaporates. But a lot of physicists argue they're just impossible because they seem to violate a fundamental law of physics about entropy. So the jury is definitely still out on that one.
So this all brings us to the ultimate question. We've got the theory, we've got the equations, we've got the cool movies, but is there any proof? Do these cosmic tunnels actually exist out there?
And the straightforward answer is no. As of today, these big gravitational wormholes are still just a fascinating possibility that comes out of the math. We have never, ever seen one, and we don't even know for sure if they can form naturally in our universe.
But, and this is a really cool but, something amazing happened in a lab back in 2015. Scientists actually managed to create a magnetic wormhole. They built this device that could take a magnetic field, make it travel through a hidden tunnel, and have it emerge on the other side as if it had traveled there completely invisibly.
Now, let's be super clear. This wasn't a tunnel for people or spaceships. It was a tunnel for a magnetic field. But what's so important about this is that it proved the fundamental principle is possible. It showed that creating an invisible connection between 2 points is physically possible. It's a huge proof of concept.
And you know, wormholes aren't the only game in town. There are other mind-bending ideas for faster-than-light travel being explored, like something called the Alcubierre drive. The concept is basically a real-life warp drive. You'd contract space in front of your ship and expand it behind you, letting you ride a wave in spacetime across the galaxy. So while wormholes are still this incredibly tantalizing but unproven idea, the dream of traveling between the stars is very much alive. It pushes us to explore the absolute limits of physics and our own imagination. And that leaves us with one last, exciting question to ponder. If these cosmic tunnels aren't the answer, what breakthrough will be the one that finally lets us take that giant leap to the stars?